Hello, everybody out there. Welcome to season 2 of Database. James, is this season 2?
Hello, everybody. I love the CEO move Jamie just pulled by calling this season 2. Now, the reality is we stopped making the database podcast because I don't know, I didn't think anyone was listening to it. But then it turns out people were. And we kept meeting people who said they liked the podcast.
People kept saying to us, "When are you going to bring back Database?" And we were like, "Oh, I didn't know anybody cared."
I got I didn't think anyone listened to it or watched it. But turns out you're out there. There's a couple of you out there and we appreciate you.
I have already noticed, James, that you are representing yourself here as Dr. James, bringing in the full power of your credentials
Yeah.
and making me feel like a moron.
I feel like we didn't have a sufficiently auspicious presence on the podcast, and I wanted to bring just a little bit of, intellectual rigor, perhaps, to
Yeah.
this podcast. So
There's going to real kind of gravitas behind your arguments today, I feel.
exactly. I hope to be maximally out of touch and academic for the duration of this podcast. So, anyway, yeah, back by, I won't say popular demand, but mildly popular demand.
Backed by moderate demand. It's
Back by
Database.
moderate demand, the database podcast is back. Now, we would love to have your suggestions for topics. And so the point of the database podcast is Jamie and I ideally have semi-based takes on stuff in databases or the tech industry. And we rant about it or, share information that you're interested in hearing, either about Convex or the tech industry in general. Typically, we like to make it about tech in general. This episode will be about Convex. But if you have any requests for future episodes or guests you want us to have on the platform, I think we already have a few folks lined up, a few exciting people who are down to be on the podcast. Yeah, let us know. We'd love to make you happy.
And James, let me ask you, what is the subject of this season 2, episode 1, our return episode?
Jamie, it might surprise you to hear, but today's subject is Convex still sucks.
Convex still sucks.
Does it?
Oh, I think it's in more ways it's good than it sucks, but it does still suck in some ways.
Yeah.
So for those loyal listeners, all 47 of you that listen to every episode in season one of our most popular episodes, maybe our most popular episode, was an episode we did called Convex Sucks. Do you remember that one?
I do remember that one. We made a website about it, in fact. You can go to a website called convex.sucks, convex.sucks, and see a summary of the previous episode there.
That's right. And by obligation, I think we will now have to go in and update that website with the new list of things that Convex sucks at. Doesn't that
Someone will
sound
have to
right?
do it. Hopefully you, Jamie. But yeah, we'll do that. Now, the point of this episode is just to obviously we don't think Convex sucks. It's our life's work. We're immensely proud of it and proud of the team. Um, but there's just we like to be pretty real here. We like to acknowledge things that we think are gaps, and we think that I don't know that integrity is probably appreciated. So this is an episode where we want to go through I think 6 topics where we think Convex, is a little bit sucks right now, and we wanna address, maybe why it doesn't suck as bad as you might think, or ways we wanna improve it and make things better in the future. As of right now, today is Wednesday, February 25th, 2026. There has been, I don't know, for the first time in maybe decades, a resurgence of interest in database benchmarks. And you and I are old men, and as a result, we remember the Oracle days, the days of Mongo and Redis, the days of people making benchmarks that didn't really matter, maybe.
Yeah.
Turned out these platforms didn't kill MySQL or Postgres back 10 plus years ago.
Yeah, I even remember in the late '90s, the, MySQL versus Postgres benchmarks of the day where MySQL would smoke Postgres, and all the MySQL fans would trump that very proudly. These were in the days when the storage engine was my ISAM, which did not really store data that
Yep,
durably.
my ICM was kinda crashy. Now, you might not realize this, the first versions of MySQL didn't, like, actually have consistency and weren't durable. Like, it was not a ACID database at the time. Um,
No.
but let me phrase this more concretely. Convex sucks because it's hard to know how well Convex performs ahead of time, right? And
Yep.
it's very desirable to have a benchmark, a single number that would say, "Convex does this number, therefore it performs well."
Mhm.
And this is a very reasonable concern. Jamie, what are your thoughts on this?
Yeah, I think it's reassuring as engineers who we always like to make everything quantitative and discrete and easily understood, right? To have some absolute number that says, convex is 10 times better than this, or this other thing is 10 times better than convex, because then we could maybe sort of project, oh, then when I have, 10 billion users, like one of them will work and the other won't, or maybe one of them will be cheaper. Um, but yeah, with especially with systems as new as Convex, which behave really differently and are designed applications run on them differently. It's very difficult to produce a straightforward number that somehow gives you exactly what you're looking for, I think.
Yeah. Now, so Jamie, we are startup founders of Convex, right? So we are biased. But in past lives, past jobs, we have run infrastructure teams with $500 million budgets, you know, and made very large decisions about databases that we would purchase for companies. And the it's very easy to think that there's a convenient quantitative answer about what the right database is to choose. And typically, that's not true. Typically, you have to choose a database based on, does it have the guarantees that you need? Does it suit your use case in terms of like ergonomics and usage patterns? And do you trust the team building it? Do you trust the decisions made? Because both you and I know that you can make any benchmark perform kind of any number if you play enough tricks about buffering requests in memory and doing group commit to the database, or maybe not even committing to the database synchronously, or doing sufficient parallelism and pipelining on the client. Right. So there's a very real question that customers have about, will Convex scale to meet my customers' needs? Right. And it really depends very heavily on your workload. Right. Now,
Yeah.
something we are actively doing right now, we're launching a enterprisey plan soon that we'll mention later on. But along with that, we're publishing some kind of standard benchmarks of representative applications. So not just like counter benchmarks, but like a real application, like a chat app or a to do app, whatever it is. Like these kind of sample applications with a large number of concurrent clients to kind of demonstrate whether Comets can scale to meet your needs. But as you as a consumer trying to pick a database, typically your question is not which database has the highest queries per second. It's, will the database meet your needs? And in
My
my
needs. Yeah.
experience with Convex, it's extraordinarily rare for someone to hit a scaling limit on Convex with respect to live user load. So we have
Mhm.
pretty high query per second traffic from stuff like T3 chat or Claw Hub, where you have large numbers of users, certainly in the Claw Hub example, very large numbers of users in spikes who show up to a website and interact with the website. And Convex is designed to scale and handle this load just fine. I think the areas where Convex sometimes struggles load wise is programmatic load, right? Because user load is really limited by how many users you have and what they're doing. And there's only, a certain number of billion people in the world. So if of them are on your website at the same time, there's a limit to how much load can be generated. But I have seen situations where someone has maxed out the throughput of their Convex instance by doing background work, right?
Mhm.
So spinning up very, very large, say you want to walk over your entire table and send a call off to an LLM to do some processing. And as a result, you're trying to run 100,000 concurrent jobs. Now, in Convex's example, that would mean you're running 100,000 concurrent isolates, 100,000 runtimes, which, by the way, is extraordinarily expensive thing to do, and you wouldn't want to do that in terms of parallelism. So typically, these use cases, and they're coming up more and more with regards to people doing agentic development, like building agent platforms, is you want to use something like a scheduling system or a workflow system. And so if you're a developer out there and you haven't worked on large scale data processing, this might be foreign to you because you might not be used to this pattern, right? But if you have, I'll give you an example. A Dropbox, one of the things we're involved in is a system called a background processing system called Live Fill, and there was replacements later on, which would walk over kind of every document in Dropbox and do some asynchronous processing, generating image previews, etc. And these systems are designed so that there is like obviously the live user facing traffic that is synchronous. So users are interacting with your system. And in the background, you have batch work, right? And that batch work should be done in batches, in groups, right? Asynchronously with certain rate limits. And so people should typically be using, say, the workflow component or the work pool component to 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 moderate the amount of load getting sent. And those are the situations where I've seen people can run into scale limits if they're not doing these.
Mhm.
So what we need to do is get people more, make it, get the LLMs more inclined to do this too, to use components to to have good architectural constructs for large scale batch processing.
Yeah, to manage burstiness and stuff like that, yeah, which is usually the real load that is trickier to characterize ahead of time. I also think there's a here's a bad metaphor coming, right? But there's a buyer psychology thing too, where do you know the channel CarWow, James?
I do know the channel car wow.
Okay, yeah, all right. So there's this channel CarWow.
I don't know where you're going with this, by the way, but
All they do is they drag race cars against each other, right?
oh my god.
And then there's all this stuff, right, where it's like the C9 Corvette has a top speed of 246 miles an hour, right, and all this kind of stuff. And people will buy Corvettes because 'cause they're like, "Well, the Corvette was 246, but, the GT3 RS was only 211 top speed," right? And then they drive 83 miles an hour on the freeway the whole time, right? So, they bought the thing that could hypothetically go 246 miles an hour when and that was a part of the identity that I'm in the fastest one or this one's the fastest, so it must be the best or whatever. And I would say developers are not immune to this, right? It's part of why we love benchmarks is like this one is still fast. It's the fastest one. Um, so that may be one kind of persona type, right? Is like the drag racing fan, right? But most customers at businesses are they're more the caged animal than the drag racing fan. What they really need to know is, am I going to be okay? Right? Like that's actually to your point, right? Like what they actually want to know is, am I going to be okay? And am I going to be okay if next year is really successful, right? Will I still be okay? And so and that conversation usually ends up being a very, very nuanced conversation, right? About what is it you're making? What does it needs to do? How many people might use it this year? How many might use it next year? And that's a less sexy answer than this one has 1,200 horsepower and that one only has 940 or whatever, right? But it's a little bit more rooted into in our experience, kind of productive conversation about what's possible on Convex and what's not with great performance, right? Where great performance in this case means the responsiveness of the system stays active enough that your users are having a great user experience. And as you said, the big variable there, once we get down to not just kind of shootout type stuff, but more into, really making people successful. It's usually about background work, right? It's about these bursty loads where they wanna do 5,000,000 things that all need to be processed, and you're like, "Really at once?" Or something different than that where we batch this up in a way that keeps the load manageable. So, I agree, James, that tends to be really where the rubber meets the road and where the conversation gets more interesting about people wanting to run load on Convex.
Jamie, this is your fault for taking us off track, but I genuinely love your car metaphor because as you know, I'm a motorhead. I'm a motorcycle guy. In fact, like I'm very into
I figured I might be teeing one up for you
yeah,
here.
I spend a lot of my
Cars.
time wrenching on stuff. I like mechanisms and machines. And when I was younger and didn't know enough about cars and bikes and stuff, I thought spec sheets were important. And I would like, oh, I want to get the motorcycle with the highest acceleration, whatever. Right? And then you get some more experience and you realize you are never gonna do that. Like I am never gonna take like a an H2R on the highway at top speed because I will immediately die. right? And so what
Yeah,
I care about is what do I enjoy writing? It's like almost all serious like racers or car enthusiasts would prefer being in an old manual Miata than a Tesla Model S Plaid, even though the
sure.
Tesla is 1 bajillion times
It's
faster.
a way
It's
faster.
just
Yeah,
not a fun car, right,
yeah.
compared to a cool Miata, right? Anyway, so I'm not saying Convex is the Miata in this situation, but what I'm saying is once you realize, like, max specs are meaningless, what matters is, does the platform meet your needs in terms of development
Does
speed,
does it fit your life, right?
and
Or
will it
does
limit you?
it fit your
Also, will it
business?
limit
Yeah,
you? Like,
yeah,
will the platform artificially limit your growth as an organization or not?
right.
I have not
Which
seen
is a very fair question to ask. That is one that, yes, we like we constantly put work into providing better and better answers for that for people. Yeah, to your Miata point, right? It's like a lot of times there's this funny thing in the I promise, James, I won't get too derailed in the cars, but there's this funny thing in the manual world where it's like, do things have long shift throws or not, right? And all this kind of stuff, or like the gearing is long or whatever, and that people will buy these incredibly powerful cars, like a six-speed car, and the thing's top speed is 230. But the thing you realize is that you hit the legal speed limit in the second gear. And so that means you only get to shift once, right? And that's not as fun as shifting three times or four times. And so a lot of people find they love the Miata more than they love the GT3 RS because you get to shift more. It feels faster, which is weird because it's slower. Anyway, all
but
this
Jamie,
comes back to
Convex
the
is still the GT3 RS, the
okay, yeah,
pinnacle of
exactly.
design, the pinnacle of automotive design,
Well, the GT,
obviously.
yeah, for sure, but yeah, of course it is, right? But I think that or maybe even the better car metaphor there is the GT3 RS versus, like versus that Tesla. We'll pick on the Plaid again, right? It goes really fast in a straight line, but it really wouldn't win a race, right? One of them has been designed to do the job, right? And the other one has been designed to be shocking and look good on paper, right? And it, it's really hard to do both of those well too, which is part of, like, we really try to focus Convex. Convex is a database to build the future on, like the actual future, right? So, like, we really try to keep ourselves disciplined because it's easy for us to get tempted by this horsepower kind of thinking. It's very easy as engineers, we're engineers too, to just be like, screw your benchmark. Let's spend all our energy taking our incredibly talented engineers and go beat that benchmark that we lost yesterday, right? But the truth is, we know that doesn't actually help our real customers
Yeah.
we have. It's not really what makes them successful. And we've really been intentional here about trying to make a product to empower people building stuff and to really try to if Convex isn't fast enough, which sometimes it's not, to really derive all of that work off the basis of feedback from real, customers and
Yeah.
projects.
And the thing that matters to your business is how fast you can move, whether you can develop your software, whether your app stays simple, and whether the platform scales with your needs. One thing I'll say, folks will put out these benchmarks, realistic benchmarks for folks who want to see if the app can run on Convex. Um, you're welcome to benchmark Convex yourself. I would recommend you get in touch first because what happens is people like start off on the tiny baby instance because like we don't know how much you're going to pay, etc. And so you're not going to be able to run like a giant mega scale workload through that without us like sizing up your deployment. So if you're a serious custom looking to benchmark an application on Convex, which I encourage you to do, just get in touch first to make sure we have your app on the real hardware.
Yeah. It might sound old fashioned, but like a conversation is still the right move on that because, I think some folks listening may or may not know this, but even Amazon won't let you just go crazy and spin up. They have all these limits you hit, and you have to reach out to them and talk about why you need more. And Convex is no different in that way. And we've learned the hard way that, like, allowing any new instance to scale infinitely is almost always a bad idea, right? Because, like, it could be a mistake, and they don't really wanna take over every computer in AWS because we run on AWS, right? So they don't really want us to try to somehow provision every single machine, that exists in Virginia in order to service their load. That probably isn't what they meant, right? So, um, or they're just kinda benchmarking us, and then the question there is always like, they're like, "Well, how fast can you go?" And if you imagine that Convex could one day take on customers of almost any size, and even today takes on customers of many orders of magnitude difference. the question we would ask back is, well, how fast do you need to go? Right? Like, it's what's the preset limit you want to see? Like, do you want us to try to hit 50 billion requests a second? Right? Like, why? Right. So that those like the kind of good faith, mature conversations about like I really want to load test this to prove you all are ready. We do those, but they normally need to start with like, hey, let's jump on a call and like, what is it you're trying to do? Like, okay, great. Like, we'll provision that for you. We'll have the Eng team ready. We'll be in the Slack connect with you. It's more that than just like I signed up at convex.dev and then I took every computer on earth and somehow tried to blast all the requests through it, expecting
Yeah.
us to do that for you.
If
Like,
you want
that's
to be
not really the
major
way these things work.
if you want to be major leagues, you're probably gonna have a conversation. Um,
Yeah, especially because that means you're gonna be risking a lot of money on us, and the chance that you do that 'cause we'll be running a lot of infrastructure for you. The chance you do that without even saying hello is just very low in practice, right? So, that is normally not the way healthy customer relationships start.
Jamie, so we've said, sure, we need to put out some more benchmarks. People should benchmark things themselves. It's extremely rare for people to hit like live site user interaction limits. But I did kind of let slip that sometimes people hit like scheduler limits, parallelism limits. Sometimes they're trying to do too many background jobs at the same time and get surprised that they can't do infinity background
Yeah.
jobs simultaneously. What's the
I
deal?
would say I would say that's fair to call that as the second thing that sucks about Convex right now, is it's too easy to use the scheduler in a way which spawns a ton of jobs and then causes you problems. So, in practice, one of the most common kind of customer interactions we have where we go, "Oh, I'm sorry. Yeah, you got yourself boxed into a corner," is that they've used our scheduler API and they've done something like, "Oh, I've got 10 million things I want to go do right now," which of course is reasonable. Sometimes you need to do that. And they use the scheduler API and basically say, "Run all of these right now." And our scheduler goes, "Okay, you really want me to try to run 10 million things at the same time that are all trying to update the same record? I'll give it a shot." So,
Well,
our
yeah,
it's too easy to use our scheduler in a way which indicates that you wanna run things at a parallelism that you don't actually care about. You do need all these jobs to get done. It's unclear how much we should move hell on earth to kind of try to make it happen, and that often causes load issues.
Yeah, Jamie, there's something problematic in here in particular, right? Because let's say I'm a customer and I have users signing up and I have a little scheduled job to send them an email to like send them their, I don't know, access credentials or welcome to the team or something. And it's pretty important these happen fast because this is like the onboarding flow. But then every now and then someone comes and says, index all my emails and send them to an LLM. And there's thousands and thousands of background jobs running, right? That could presumably create head of line blocking, right? Where all those scheduled jobs get in the way of the user signups. And so all of a
Exactly.
sudden, like you'll have a like maybe an hour delay before a user can sign up because there's all this background work getting in the way. So what should folks do about this? This is like seems like a I don't know why I'm acting clueless here. Like obviously
J-Pop,
I'm
I
doing
think
this
you
to
might be
spend
talking
it is,
about the
Jamie.
work pool
Yeah, how does
component.
this
Yeah.
work? I'm trying to set you up here, but like, yeah, what do people do in this scenario? And is it
Yeah,
a
so
real concern? Yes, it is.
if you go check our component directory at convex.dev/components, the most popular components installed by far is the work pool. And there's a reason for that. It's that, essentially, I would say every large customer of Convex, to be honest, every medium customer of Convex, in fact, these days, most small customers of Convex, pretty early on discover that the work pool is an incredible tool to be able to create a pool of work, thus the name, with a abound amount of concurrency, right? So you can say, no matter what else is happening on my system, I'm going to have this like send confirmation emails, like pool of work that I want to be happening in the background. But I don't ever want you to run that more than 50 at a time or something like that. And what that allows you to do is you can burst all this asynchronous traffic, like get this work done as fast as you can, but don't starve every other thing in the system that's trying to also happen. And so by doing that, yeah, you could start to organize your background work and monitor it, right? So you can see how long is the queue and, the kind of background email thing. Okay, great. Well, we just got a bunch of new signups or whatever. But during all that time, your site stays responsive and, new requests to sign up succeed as well. You're not completely bogged down your system with like trying to send 5 million emails all at the same time.
Yeah, so this the work pool is basically you think about this as separate scheduler queues. This is a
Mhm.
common architectural pattern, right? You might wanna have your user signups happen at a certain frequency, and your batch work can happen in the background in a trickle, and it can queue up when there's a big spike in load, and it can drain when load subsides. There's a few kind of, insidious technical details in here, Jamie.
Yep.
Um and I'll dismiss one real quick because we just made scheduler latency 10x lower, actually almost 100x lower, to be honest, but over order of magnitudes lower yesterday. But there are still some issues with scheduling. One is latency calling into convex components. So maybe you want to explain what a convex component is, but there's a bit of a fixed latency for calling into components. So there's a bit of a fixed latency currently for calling the work pool to begin with, and
Mhm.
also sometimes the work pool isn't as high throughput as it could be. You know, you and I, as systems engineers, know deep down inside the work pool could be better.
Yep. Yeah, inside of Convex right now, excuse me, we kind of have this small list of missing primitives that have been on the to-do list for literally 5 years, and we've just there's always been more urgent work to do, but now it's starting to get more and more important to take on. And one of them is that despite the fact that you all benefit from awesome client-side reactivity, there really is no good way to have server-side reactivity in Convex right now. And so what that means is if you're trying to do something like process all jobs that haven't been run yet, where those jobs are some kind of query into a table. There's not really a great way to do that to just like trigger something to run and to consume those jobs and to execute them. And so when you're building components like Workpool, writing them in a way where you don't like essentially cause contention. Like some people using Convex may have seen the dreaded like OCC error, right? Which basically means everyone's trying to update the same document at the same time. It's we're missing this server side reactivity, which would be a really effective way to be able to minimize the kind of contention for records in components like workflow. And there's some changes we want to make in order to make that happen. And some of those changes might, hint, 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 be related to Convex 2.0, which we've started to mention a little bit
Yeah.
online in various places.
I want to give an example of a customer issue that I jumped in on because there was a customer that actually ran an election on Convex, like a kind of major election on Convex, and voting systems are actually kind of a little bit tricky to implement efficiently. Because the naive way to implement that is, like, every vote gets added to, like, a tally, and everyone subscribes to all the votes, and they add up all the votes, and so you have this huge amount of contention meaning, like, a lot of people are writing to data while other people are reading data at the same time, and it limits the throughput because 'cause they're all trying to read and write the same rows at the same time. So typically what you want to do with a say a voting application, like a live election application, is not have everyone subscribe to every vote and add them up synchronously, right? You want to have people adding votes to a one way of architecting this is people adding votes to a table, to a log, right? And have a background job periodically aggregating them up, adding them up, and writing a tally to a single document, right?
Hmm.
So everyone subscribes to the vote tally, and you might say, "Hey, that's not strongly consistent." Yeah, it's not strongly consistent, right? You're able to opt out of consistency in Convex. You don't have to when you go to the voting page, you don't have to see the exact count as of the last millisecond. Maybe you can see the exact count as of the last 2 seconds. And when you go to YouTube and you look at the how many votes a video has, that's not live, it's almost live, right? So to build this kind of application, it'd be really, really helpful to have a singleton. And a singleton is like a single background process that sits there, and every time enough votes shows up or a timer fires, it adds them all up and it increments the tally. And that's an example of the kind of thing that's a little bit tricky to implement efficiently in Convex right now. Now
Yep.
we could and we probably should just write like a voting component or something if you want to do this kind of thing. Like a now I'm not saying you should necessarily run your national elections through Convex, but you know, maybe you could, but like you could for stuff like YouTube kind of boats and stuff. So this is like a common use case where it'd be so much easier to build this if you did some kind of server-side reactivity. If you had like a single blessed function that just sleeps and wakes up whenever there's more work to do, it's coming.
Yep. So in your use case, yeah, this what this singleton would do would basically be like read any new records out of the votes journal, right? And then any new ones that show up, I'm going to add them all up and update the single tally that James said. And the thing just goes to sleep and then it gets woken up reactively whenever there's new votes in the table, right? So this would be really easy to build if server-side Convex had the same reactivity that client-side Convex has, but actually right now it doesn't. And so that's something we have to fix very soon, and we intend to.
Now,
One of the things you mentioned, James, I wanted to call out though, is that you kind of talked about components and like the latency,
yeah.
the latency around components, which we hear about sometimes from users. So yeah, that
Now,
what do you think about that one?
what is a component? So a component in Convex is this kind of magical new primitive that is kind of like a library and kind of like a service, right? So within your functions in Convex, you can call into components. They have their private namespace, so they have their own tables that they can read and write to that no one else can access. They're kind of hermetically isolated, and interestingly, in components, you don't have to think about this often, but components execute as sub transactions, right? So you can have like a function to create a user which calls into a component that does some provisioning activity, right? And if it aborts for some reason, like you throw an exception, everything either commits or aborts atomically. So when you're using components, you don't have to think about race conditions between services like you would with a service-oriented architecture. So components are cool. Components are very like interesting, novel technology. And what I love about components is you don't have to think about the novelty when you use them, right? They just seem like they just work, like they seem like functions that just work, right? So components are like the building blocks of extensibility for Convex. And we actually plan to move some of our core features out of the core into components. So for example, if I had my way, I say if I had my way, I guess I am the CTO, so maybe I can have my way eventually. But I would like to have file storage not be a core part of Convex. I would like for crons not to be a core part of Convex. I would like for scheduling not to be a core part of Convex. And these to all be components on top of a very small core. And so we can make this core of Convex just super efficient and polished and have more features on the in user space, basically. If you know much about kernel programming or operating system kernels, right? There's the kernel itself, which is a very small kind of protected piece of software, and then a lot more functionality on user space. All of this depends on components being fast,
Mhm.
right? And so right now, I would say components are perfectly fast if you want to call a couple of components in a function, right? So I don't know what the example would be. I mean, one example is if you want to use the work uh, pool component and you have a new user creation script and you add something to function and you add something to a work pool to send them an email, right? No big deal. A little bit of additional latency because when you call across the component boundary, currently we spin up an entirely separate V8 isolate, like an entirely separate kind of runtime, bootstrap it with your modules and run it in there before returning to the caller. Now, where this doesn't work great is if you want to call 1,000 components in a single function, right? Because that additional latency is multiplied by 1,000. So this is the third thing that sucks about Convex. One is hard to know how well Convex performs ahead of time. Two, sometimes large customers hit scheduler parallelism limits and you have to architect around it. And three, latency can be high when you run components. Now, the latency is high when you run many components from a single function. We want you to be able to do that in the process of fixing this right now. So we're using V8 contexts and reusing them across calls to the same module, the same function in the same permission space. So basically, you can reuse the same environment without spinning up a new isolate. Um, so I guess all I have to say about that, we'll put out like a blog post probably or some information about how we did this. This kind of interesting technical challenge, but we expect component latency to go down tremendously in the coming weeks.
So it can be, many calls into a single component. It can sometimes be one call into a really, really large component too, right? Like, for example, I think we'll probably talk more about this soon, but a lot of people ask us, why is Betteroth so slow inside Convex, right? Do you know why Betteroth is so slow in Convex?
Overall, it's enormous, Jamie. I can
'Cause it's big. Yeah, it's big. So Better Off, are really architected for kind of a world, where, you're doing something like using Express and talking to Postgres or whatever, where it's a long running server, right, that loads the components and then there's a request handler. And so this environment like Convex where you have all these separate isolates that are, acting as a kind of graph of computation, it's kind of incompatible with the assumptions Better Off makes about, like, how much code it's pulling in and how much that overhead matters. So, to James's point about, like, yeah, when you call into the Better Off component, if we don't happen to have the Better Off component, like, preloaded and waiting for you inside of an isolate ready to go, then you've gotta wait for all that code to load. And it has a lot of code. It's pretty it's a code base with a lot of dependencies, and the bundle is pretty large.
So all we need to do there, Jamie, is just to have this preloaded, pre-cached. These are not intractable systems problems, just work we have to do. And in fact, the team's working on some of this stuff right now.
Yep. Yeah, the more you can just keep all of these components just preloaded and have the ability to, you know, clone or something, a parent of some kind in order to create a almost copy on write child for whatever that specific invocation is, the better off you are on being able to just not have to worry anymore about the overhead of loading components. But our current system is okay at that, but not great at it yet. And there's a lot more we could do there.
All right, Jamie. So enough scaling systems database
Yeah.
points.
Well, let's
Let's
see,
talk about
not a
features.
non-scaling systems thing. We just mentioned better auth, so I guess it's fair to call out that auth is still pretty confusing
Yeah,
when it comes to convex, and despite the fact that auth is something that, we put a lot of time and thought into, it's still not perfect and has some real problems,
yeah.
using convex with auth. I mean, there's a lot of different ways to do it, right? So we have we have the better auth component, which we just mentioned. We've got convex auth. We've got these providers like Clerk and WorkOS. And sometimes users say, what do you guys want me to do?
Yeah. Let me
Yeah.
pose a critique to you, Jamie, because
Uh-huh.
recently we did a day called Build on Convex Day. We every now and then the team just builds apps on Convex, and so I built a pretty sizable app using open code on Convex, and I was actually I probably shouldn't be, but I was like shocked at how well it went. Like I was couldn't believe how well Claude was writing Convex code. There was just zero missteps almost for the entire day, except the first hour of the day sucked. Because the first hour of the day was me trying to bootstrap a project, figure out what auth provider to use, and I got in some kind of weird auth mess. And it really made it clear to me as a Convex customer, not just a Convex developer, that the auth story is still confusing and it's still probably the biggest friction point for new projects.
Yep. I think that's true. And of the four options I mentioned, Clerk, Better Auth, Convex Auth, and
OS.
WorkOS, the truth is they all have different strengths and weaknesses where a lot of what we're trying to do in various ways, whether it's working with a partner or whether it's our own engineering work we do, is try to make a set of recommendations that feel strong in all different ways. They bootstrap easily. The scale at scale, they have the features, the enterprise features you need, right? They are kind of architecturally compatible with how Convex works, right? And so each of these providers has different places they're strong and they're weak, right? So Convex Auth, because we built it, is quite simple and definitely is architecturally compatible with Convex, um, and is pretty low overhead and pretty fast. But it doesn't have, it's missing a lot of features compared to the others. And then the others have features that, Convex Auth doesn't have, but they're either harder to set up or they get expensive sometimes is feedback we hear from other customers. So these are always things we're trying to listen to everyone that's tried all of the different paths and just hear What are you happiest with? What should we spend more time on? But from the outside, if you said right now, feel like the guidance from Convex is not very clear about auth. Yep, that's a fair criticism.
You're
That's
correct.
something we have to continue to figure out.
Now, fortunately, this is generally an issue that just affects Project Bootstrap. There are some folks who sometimes hit limitations with auth providers later on in their life cycle. So sometimes folks will want to, even though like Convex Auth, for example, is very easy to get started on and is it solves your needs for most customers doing kind of small stuff. If you ever want to have a large scale application that has single sign on and kind of sophisticated auth features for business customers, for example. Some folks want to start with an integration like the Work OS one, where you're kind of starting off with the enterprise grade thing from day one,
Mhm.
or clerk. Um, but yeah, I think all we can say about that is we acknowledge that it's a problem. I think we don't. I think the fragmentation can be confusing for folks. Um,
It can, yeah. We have one of the reasons why we have spent a lot more time with WorkOS recently is that the set of customers we have using WorkOS right now end up happiest in the long run. And the WorkOS team has been awesome to work with in that a lot of the ergonomics around bootstrapping and stuff, they've actually been really good partners in working with us on trying to improve things over time. Having said that, I know there's still a lot of work we need to do
yeah,
together to
not
make
perfect.
the bootstrapping better. Um, but yeah, but then the other thing too is that we've kind of put Convex off on ice, and to be honest, there's enough interest in us improving our built-in one that maybe that was a mistake, and we've had stuff like um, Robel do some work on convex auth and, I think turn into a component in like a weekend, right? And so because LLMs have just kind of changed everything in terms of how quickly you can get work done, it is causing us to reevaluate things like, well, geez, should we have some kind of investment into convex auth going?
Yeah.
Um,
I think something we can acknowledge is there was a point, Jamie, you and I kind of thought, well, Better Auth looks really promising. Maybe we could just like get rid of Convex Auth and just
mhm.
have Better Auth be Convex Auth. Like this is a while ago, early in the project where it was quite simple. And it seemed like we could make this kind of the official way of doing auth in Convex. It seems unlikely that's going to be the case going forward. Better Auth has grown to be a rather large kind of platform in a way that seems
Yes.
that probably won't serve as like a drop-in auth service for us.
Yeah, what we really wanted from Better Off was something really good and well maintained and simple. And Better Off is not simple. The other two things it might be, but it is not simple. And so a lot of the other parts it has associated with it, where it's adding value with things like billing and like its plugins and stuff like that, convex developers don't need. And to be honest, those things create like data um, residence, like data, like architectural, incompatibility with convex components in many cases in ways which just end up confusing. And so that's the reason why I think that Better Auth, I totally understand why they're making what they're making. I think unfortunately it's a little bit strategically incompatible with being the right solution for convex. We almost just wanted a better auth.js. All this other stuff is cool, but it's not useful. In fact, it's actually kind of a little bit detrimental to convex customers.
Yeah. Now, so Jamie, if we go through the list of kind of the top concerns about Convex, right? Obviously, scale questions we've already covered. Auth confusion, that's a big one. People would
Mhm.
complain about lack of EU support all the time. We have it now. Uh, Local first comes up a little bit still, but the other kind of big question mark is around aggregates and analytics in OLAP,
Yep,
and the phrase that aggregates in Convex suck.
they do, yeah. Yep.
I think it's probably fair. I think
Mhm.
that's a fair critique, and we can talk about why that is, and it's intentional. It really is intentional that they suck. It's a strange thing to say. They have not been designed to be good in Convex. So Convex is designed currently to be a very reliable, simple, scalable, low latency transactional database that you build a user facing live application on and put it in front of your users. Now, there's entirely different. set of workloads that you might hear us call OLAP. So just to summarize what these mean, there's something called OLTP, which is online transaction processing, and then OLAP, and I'm assuming the OL stands for online. But
Online analytical processing?
analytical
Yeah.
process. So the difference is, right, OLTP, MySQL, Postgres, Convex, whatever. OLAP, Databricks, Snowflake, DuckDB,
ClickHouse.
ClickHouse, right? Different kinds of systems with different kind of architectures, and in particular, generally, OLTP databases are stored internally as row stores. So each row in the database is stored contiguously on disk. And analytics databases are typically stored as column stores. So you can kind of walk over an index doing a range scan out of the database very efficiently. So OLTP databases are designed for very efficient transactions. Read a bunch of stuff, write a bunch of stuff, do some computation in front of a user. And OLAP systems are designed for batch processing. Add up all the users in my system and figure out how much they paid this month, right? And typically you use like even at Convex, we actually use Databricks at Convex for all our billing and things. And so when you go to the insights page on the dashboard, most of those metrics are coming out of Databricks. They're not coming out of I mean, obviously Convex is generating them and streaming them to Databricks, and we're running background batch processing. All TP needs to be low latency and consistent. OLAP is almost never consistent generally, and it can be high latency but big. It's kind of like it's precise versus batch and bulk, right? Now, Convex has no built-in OLAP support,
Mhm.
and aggregates. What is an aggregate? An aggregate is like an aggregation of information about a table. So an aggregate might be the sum of all rows in this column, right? Aggregates are a form of OLAP too, right? Now, it is true that Postgres will allow you sometimes to compute aggregates and OLAP style queries on your transactional database, but it is a terrible idea, right? Because it will work at low scale, but at high scale, if you have any query that tries to add up all the columns, or do some kind of aggregation, it will be very, very inefficient because it's not designed for efficient querying processing, right?
Yep,
So,
and
uh,
it will slow down all that live traffic too.
yeah.
Yep.
So we have some hacky solutions in the meantime, right? There is an aggregates component in Convex. It's a little bit too hard to use, I think, right? So we have aggregates. You can do it, right? It's done through a secondary B tree, which computes this stuff efficiently. And there's an aggregates component for doing this. We need to make it a little bit simpler to use, but you can do aggregates in Convex. It's just kind of designed in the right way, right? Um, we could also probably have built-in count and things like that in Convex, although I think making the component really easy to use is the right choice. You cannot currently easily do a very large table scan in Convex. You don't want to have a query that reads 1,000's fine. You don't want a query that reads 1,000,000 rows and processes them in the live transaction path. You can try to do that on Postgres. It will grind to a halt as soon as you have any kind of popularity. So what are we gonna do about that? Well, for any large customers, they should be using a dedicated analytics database. As of right now, 2026, Convex is not planning to compete with Databricks and Snowflake, right? We're not trying to be your business intelligence platform. Um, they're just very differently designed systems. Um, so people right now who have large companies built on Convex, they use our Fivetran integration or whatever, and they stream data out to an analytics database and they do their queries there, right? Uh, that's where you can run your SQL and like do a big kind of batch SQL query to compute kind of offline stats. We will add built-in OLAP because people just need it enough. And what we're realizing industry attitudes change. There was a time a little while ago where you could say to someone, "Hey, you shouldn't." I mean, I'm already making this mistake right now, right? Because I'm trying to tell you all, like, "Hey, you shouldn't try to run an analytics query through your transactional database." And probably as a potential customer, you're like, "Well, James, I don't care. I just want to run this workload." And you're the guys who are meant to make this problem go away for me. And yeah, fair enough. That's a good point, right? So what we need to do is have some built-in OLAP thing. Once upon a time, we were saying that we were going to have DuckDB deployed within Convex. we even have a prototype of that. It's possible it'll be ClickHouse. I don't know actually. We have a few prototypes. The honest answer is we just haven't built this. We have prototypes. We haven't built the industrial grade version of this yet, but we will add built-in analytics to Convex. It will be separate, like inside. From your perspective, it'll be like the same system, right? But internally, they'll be separate systems. Like we'll store that data differently because there's just different architectural choices you make.
Yep. The this definitely comes up that some users will run into this and kinda ask us about it 'cause, admittedly, the concept can feel a little confusing. But what I will say is that agreement for your transactional database to be willing to pretend to be an analytical database, in my experience, having seen a lot of these projects and companies over the last 20 years, um, that is almost always your first significant outage. It is when your product succeeds and gets traction, you suddenly realize all those any table scan has to come off of your OLTP database, and then you sit there and go, okay, well, let's run it on the replicas. And then once you're running on the replicas, you go, well, it's not consistent anymore anyway, and that never mattered. So, oh, that's what Snowflake is for, or that's what ClickHouse is for, is it does the same job and it will do it 100 times faster and much cheaper, right? So that whole this idea of OLAP, if you're looking for signals that maybe that's what you're looking for, the biggest maybe user-facing difference you would see between an OLTP workload and database and OLAP database really comes down to indexes, right? So OLTP databases have this concept of an index where I want lookup on this field to be fast. And so if people are making a dashboard or they're computing aggregates or something in Convex, given a lot of different like, oh, I might want to add it this way or that way or across these fields. If you find yourself starting to add indexes to every single field in the in the database, that probably means that this is actually kind of an OLAP use case, and you want to be able to scan this data any way you want, and you don't want to add indexes to every single field. It's just kind of not worth it. That starts to feel awkward, and you're almost writing a query planner in Convex where you have all these if statements in TypeScript to use this index or that index depending on like what control they selected on the UI. So once you have something that open ended, you're in the range where these databases James mentioned that are these OLAP databases, they organize everything by columns to make scanning for, across all fields really efficient, even if there's a lot of data in there. Um, and once you're using one of those for those kinds of queries, they're just way, way better at it, to be honest, much faster and much cheaper. And so at Convex, it may feel like, oh, you're introducing this idea that I used to not have to care about. But that's because, yeah, as you probably have felt already, Convex tends to have this bias towards steering you toward things will work in the long run early, even if they're a little bit more surprising. But what we want to do is, I think, a key part of how we need to figure out how to deliver this eventually is help to use runtime feedback to give agents and stuff like that information about, hey, this query is touching a lot of records. Like maybe this should use the OLAP system. And so the good news is, I don't think this has to be a thing where everyone that just wants this problem solved suddenly has to become an expert on OLTP or OLAP. I think one of the opportunities Convex is going to have is helping this get solved the right way and using things like modern tools and LLMs so that many of these things happen somewhat automatically, being data driven.
Yeah,
So we'll just learn more about that when we get there.
Jamie, to that point, lately I've been getting a lot more folks telling me they just don't care, and I think that used to annoy me. And now I realize the tide has turned, right? So there are folks who will say, I don't know what an OLTP database is or an OLAP database is. I don't want to know what it is. I don't
Mhm,
care. I just want you to make my app work.
mhm,
Because guess what? Claude's writing my app anyway, right?
mhm.
And I thought you guys were the back end. And yeah, I get that, right? So, if you're listening to this podcast, you probably care about these distinctions. But the reality is we just need to make it so that agents know to do the right thing. We're going to give
Yep.
feedback and say, hey, yeah, that query looks pretty inefficient. Perhaps you want that to be an all up query. And it'll be instead of ctx.db, it'll be called ctx.analytics or whatever we'll call it. Um, Now, a
We're
few
we're
things.
we're just gonna give you the version that works for 1,000,000 users too, and not just for 1,000 users.
Yeah, yeah, it'll. it'll actually work. We want to give
It'll
you
keep
we
working.
don't want to trick you into building things wrong. I hope this is probably obvious. Convex, the main goal of Convex is to try to help people design things the right way. Like the right way, meaning ways that kind of scale and are extensible, etc. Uh, I will say on that point, when we add analytics support, it probably won't be consistent. It probably won't be reactive.
Right.
Meaning if you add a user to a table and immediately run that query, maybe you won't see that user for a couple of seconds. I don't know. There are ways we can build around this to make it work, but it might not matter. Also, probably you won't be able to subscribe to an analytics query and have that update. Haven't
Yep.
decided on these, but it's just this is the systems is all about trade-offs. I mean,
Mhm.
Jamie mentioned this. Jamie wrote a blog post about benchmarking today. If you have sufficiently smart people in an organization, systems is all about which intentional trade-offs do you decide to make. And if we decide to not make analytics queries reactive and not make them consistent, we can just make them faster and more scalable because we as systems engineers think that you probably don't need those features. I think you need consistency and reactivity in your transaction path. Absolutely. But probably not for your analytics.
Yep.
Um,
Agree.
okay, Jamie. We've covered scale, we've covered features. What about
Yeah.
business? What about,
This one's kinda it's
what about
one
business
last thing on the business side that we run into again, because all these are based on what are the conversations we find ourselves in with users and customers over the last few months or the last year. Um, and so this last one I think is it's not clear if Convex is ready for enterprises.
Yeah, I think it's
Which
like,
for
is
yeah.
Convex enterprise grade or
Is Convex enterprise ready, right? Are enterprises using Convex, right? Um, and for some people listening to this that are building hobby projects or maybe just getting started, they might not care very much about this, and that's okay. Other than maybe you want to de-risk, like, hey, if my business grows, or is that going to be okay? It's a little related to scaling, but we have learned through building this business, there's a lot more than just the scaling side, right? That eventually comes in, and so some of that stuff is around, "Hey, Convex the Pro plan is 25 bucks a month," and then, like, Amazon, I can get, like, pre-commit discounts, right? And I can get, we can sign a master service agreement and a BAA, and I can get access to the SOC 2 report, and, they can tune infrastructure to lift limits for me if I have private infrastructure. Can I get dedicated infrastructure, right? So, there's a lot of these things, SLAs and priority support policies. If I'm down in the middle of the night, can I get someone to help me? So um, it ends up bigger businesses need all these things. And if you just look at our price sheet in convex.dev, you might say, well, I'm not sure if you guys are doing any of this because I certainly don't see any place to buy that. Um, and the truth is we are doing this and we do have these customers. And what we've been doing is I would say kind of piloting these as kind of enterprise relationships with, these existing customers that we've had, and that sort of came in building proof of concepts anywhere from 6 months to 18 months ago, and a number of them now have onboarded. We're about to publicly launch our enterprise plans that we've kind of co-developed with some of these customers. And so all that stuff about like, do you have SLA service SLAs? Yes. Do you have, are we willing to do an enterprise agreement where we have lawyers send red lines at each other if there's something specific a company is concerned about? Sure. Pre-commit discounts if you are want to pay annually instead of using credit card. We wire each other money. So I think all of this kind of stuff, like the support and the downside protection, like all these things you realize bigger businesses need, and it's how they buy and how they evaluate the sort of full solution. Because you do understand you're making a many year commitment with Convex when you work with us. We do have these relationships. We haven't publicly opened them up to everyone yet, but we're about to do that in the next few weeks. So,
yeah, and this
but it's very fair to say right now you could definitely look at Convex's marketing pages and just be like, is anyone besides a brand new startup using Convex yet? Do they know how to manage those relationships? And the truth is, we kind of do, and we're getting better at it every month. And we are already keeping a number of bigger customers happy, and we're about to broaden that program very soon.
Yeah, if you're a user right now on the free or starter plans, for example, and you're getting community support in Discord, and you're running on infrastructure that's honestly very cheap for you to run on, from my perspective, you might, and looking at our limits page, you might not realize that we have some customers with hundreds of thousands of deployments. We have some customers running on dedicated hardware, all to themselves. We have some customers who not only have Slack connects with us, but like we have meetings with them to talk through their architecture. And that's just how the world works, right? If you're paying $25, you're probably not going to get that, right? I'm probably not going to have a meeting with your team, right? But but that's just like we want Convex to be for everyone. And we're kind of slowly moving up the scale. We certainly don't want to neglect our bread and butter, which is like, startups and people bootstrapping applications and getting going really fast. But yeah, we start small, and then over time you get larger and larger and larger customers. And so now what we're doing is launching this plan. We have a lot of kind of much bigger customers coming on board, and these are just different kind of people, different kinds of teams. They might be environments you're not familiar with. They have chief information security officers and legal teams and all sorts of things, right? And they pay a lot more.
Mhm.
And if you're not one of these people, then great, because they pay money to help convicts run. That's the end of the day. Right? These are great customers for us. Just a different world. So yes, there is an entirely different, maybe invisible world of customers that run on Convex, that you may not be exposed to currently. But when we ship the enterprise plan in business plan in a couple of weeks, there'll be a bit more transparency about that.
Yep. Cool. That was 6. Is that I think we had 6 last time, right? I
We have
th Did
6.
we
Let's
Okay.
summarize, right? Hard to know how Convex performs ahead of time. Large customers sometimes hit like scheduler, parallelism, background work limits. Component latency can be high. Auth's confusing. Aggregates still suck. And Convex isn't enterprise grade, or is Convex enterprise grade? The website doesn't say that it is. I think that's probably 6 good reasons that Convex sucks. Um, Most of
I
these we
agree.
have some pretty good answers for, although I guess we don't have a great answer for Auth yet. And we just saying
Yeah.
what's coming eventually. So I guess you'll have to trust us on these things.
Yeah. The
Yeah.
timelines on all this stuff is like, you know, as soon as we can, which I know is a but some things are definitely within a month, some things are probably within 4 months, some things are, boy, I hope by the second half of the year we can get to that. And this is a great moment to talk about hiring, James. So let me
Oh
pass
my
the buck
god.
to you on
All
hiring.
right, here we go. If you are an engineer, a very talented, ambitious engineer who is feeling uneasy about what's happening with AI and the world changing, and you're seeing people just, replicate code bases using LLMs, and you're like, wow, what does this mean for me? I don't want to fall behind. And you want to be at a company where architecture and innovation and thinking for yourself is deeply leveraged. I think Convex is the company for you. And I think the reason why I think it's very important that that is business aligned. Like Convex is the kind of company where like we have to do things in new ways that haven't been done before, in ways frankly that LLMs are not capable of doing. Um, and obviously we benefit from the growth in LLM development because this is more applications getting built on Convex, and Convex is growing really, really fast right now, and this it's almost a struggle to keep up sometimes. But we have like a capitalist incentive to have people here who are able to think architecturally and deeply. Not every company is like that. Um, so if you're the kind of person who wants to be doing like leveraged thought work, now it's not we don't sit around thinking all day, We build stuff and we have to be very pragmatic. But if you care deeply, deeply about architecture and engineering innovation, I think you would enjoy being here. And I'm very actively hiring right now. Now, the caveat is primarily hiring in person in San Francisco. If you're considering moving to San Francisco, I would recommend this is a good time to move to San Francisco. I know San Francisco has all the problems that you've heard, and it is true, but it's an exciting time. There's a real buzz in the industry right now. This is the kind of place to be right now. We do have some remote contractors and a few remote roles, but primarily in person out here.
Cool. Great. Sign me up. I'll apply.
Jamie, you should come work with Convex.
All right.
Convex.dev/jobs or jobs@convex.dev. Yeah, best to email that instead of messaging me personally because sometimes I fall behind. Sometimes my scheduler backlog increases with outbound and I fall behind emails. All right. Thanks, everyone.
Cool.
Next episode of Database, it won't be about Convex. It'll be about something technical.
Something else.
We haven't decided yet. But
Yeah.
this is not meant to be a Convex shill podcast. It's meant to be a podcast about interesting data-oriented stuff.
We'll have to just highlight the hottest of hottest takes we've got somewhere and just draw a bright red line, a bright red
Oh,
circle around it.
God, but open source and taste and testing and all sorts of things.
Oh, man. All right. Looking forward to it. Well, that's it for episode 1 of season 2. Convex still sucks, and off we go. All right. Thanks, everyone.